Hi, in this video, we're going to look at the direct API calls to devices. So we're going to use application programming interface, in short API, to communicate with the network devices for some of the network devices that supports it. So for example, the iOS devices, the old iOS, traditional iOS devices do not support an API interface. And so it's out of the question. You have to use, say, Paramiko or Ansible, which uses Paramiko underneath in order to communicate and manage the devices automatically. However, for the newer devices such as the Arista devices, the Juniper devices, and the NXOS devices for Cisco, they do support an API interface, and it's, in my opinion, a better way to interact with the devices, as we'll see in a bit. So in particular, we're going to use the NXOS API with NetConf and NC Client to demonstrate the API interface on the box. So some of the advantages of our API over Paramiko is that it's more predictable. It's instead of string scraping or having unnecessary characters and spaces, that you have a much more clean output that comes back and is a structured data, as you will see in a bit, in JSON format. So the structured data is so much easier to consume by your program and so much easier to read, and is more structured. And so that is essentially a huge advantage over something like Paramiko that is just meant for human beings as opposed to meant for computer programs. And because that it's more structured, it's more predictable, it makes it more scalable to use this way. So disadvantage of the current networking API, I want to make specific that this is about the networking API, that it's, in my opinion, that it's a bit fractured and inconsistent between vendors. You have differentiations between, using NetConf versus just a REST API. And the structure is even different between, say, the ACIs versus the NXOS, for example. And there are different libraries amongst vendors. If you're predominantly a Cisco shop, they'll push you for libraries that abstract you from it. If you're a Juniper shop, they want you to use PyEZ, Arista, so on and so forth. So these two disadvantages of the current networking APIs. And in the future, maybe the Yang model as a consistent modeling language for different vendor networking devices, maybe that would be the answer. Or at least in the future, there'll be more abstractions such as using Ansible, Napalm, or some of the other frameworks and libraries. So let's look at the NX API demonstration. So in this viral lab, I'm actually just using one NXOS device, nice and simple, nothing too fancy about it. I wanted to mention a workaround that I had to do for, at least for Viral 1.3, that hopefully by the time you saw it, it would have been fixed. But for me, I actually have to go into interface management because it was showing down. So I actually have to go into interface management, put into speed 100 as opposed to 1000. That was the default. Shot no shot, and then add a, this one is, I believe it's optional, but I added anyways, the default route for the VRF management. As you know, NXOS by default puts the management into a different VRF than the default VRF. So therefore, I put in a default route, I shot no shot, and now it's reachable. I've also turned on the NX API feature, which is required, and NX API port to be 80, and also I've turned on the sandbox. And this is a very handy feature that you will see in a bit that will help you tremendously to look at the initial scripts that you will write. I also want to mention that, of course, these will be included in the notes, that there are certain packages that, again, that you need to have in basically to install the necessary packages, and you want to clone the GitHub for the NC client, and you want to install that NC client for yourself. So once you have enabled the sandbox on the NXOS device, if you go down to IP address and use the username Cisco, then you will actually come up to this MPI developer sandbox. And it's really handy because if you just do show version, you will see the same request will be converted into a request for you here. And if you do the post, it's going to actually show you, oh, I had a typo. So if you just say, and therefore you have an error that says, invalid parameters. But if I, type in correctly, show version, and I do the post, you will actually see the request and then the response that comes back. And you could see this is a structured data that you could parse out really easily using your Python script. And what's also handy is you have this Python button right here that you could just press the Python button, and you actually copy the Python script that you could later on just using almost verbatim outside of the box. So on the host itself, if I do the list, because I cloned the NC client, that's why it's right here. But the indexOS API.py, it's almost from what I just copy and pasted from the sandbox. I could take a look at this real quick. The script is almost verbatim, and all I changed was the URL, the switch user, and the URL of the device, and which in this case was 172.17.1.91. And I also added the pprint in order to pretty print the output. As mentioned before, I changed the username and password in order to fit what my situation was. The stock script that you copy from the sandbox will stop at the response, and what I added was to pretty print this response and also to show you how you could structurally parse out the data from that response. It's very hierarchical, so you have the high level results into the body, and within the body there's several parameters that's included, and for me in this time I'm just parsing out the host name. So let's run this script, and you could see that the output would have been parsed back. So if I scroll up on the output, that you could see this is the pretty print response, and it's very structured. It has the JSON RPC version, essentially what you saw on the response object back in the browser. And what's neat about it is that because it's a structured data, that I'm able to, if I just wanted the indexOS hostname, then this is the hostname that I could parse out. So in summary, in this video, we saw the API calls are much more reliable and consistent than Paramiko. However, not every vendor or device supports API calls, and when they do support it, they might have to use different libraries, they might have to use different clients that you could use. However, it's still better than screen scraping, and the structured data just is so much better than unstructured data, such as what you will get from Paramiko. So because each vendor has a different approach, you need to read their documentation, be familiar with them. In the future, maybe there are different approaches that will solve this, such as the Yang model or a more abstraction layer like Ansible and Napalm. But in the meantime, if you want to use API calls, then you probably want to be very familiar with the vendor's documentation. So in the next video, we're going to look at contiguous integration using Jenkins.